In this video, we're going to continue to prove that triangles are congruent with two new methods besides the two that we learned. As a review, we learned about the side-side-side congruence methods to prove that two triangles are congruent. And as a quick review, that is, if you have three sides of one triangle that are congruent to three sides of another triangle, then those triangles will be congruent. Not just the sides, but the angles also. As a review, the side angle side is if you have two triangles that have two congruent segments to each other, and the included angle is also congruent, then the triangles are congruent. Once again, included angle means it's between the two sides. One of our new ones for today is the angle side angle postulate, the ASA congruence postulate. This states that if you have two angles, hence angle angle in the theorem, two angles that are included to two angles that are congruent to two angles in another triangle, and the side that's between them, the included side, is also congruent, then the triangles are congruent. So the picture might help you understand it better. If you notice, you have an angle here that's congruent to this angle. You have a side, and finally you have another angle. So the side is between the two angles, hence ASA. And so let's talk about included side real quick. Once again, the side between the two angles. So if you look at this first triangle, what side do you think will be the included side? Well, it's going to be GI because it's between the two. On the next one, the included side would be HI. And finally, on the third triangle, the included side would be GH. So the included side is the side between the angles, just as the included angle from yesterday was the angles between the sides. So take a second and try to name the included angle, or I should say the included side here, for these angles right here. All right, so the included side between angle Y and angle E is going to be segment YE. The included side for the angles E and S is going to be segment ES. And finally, the included segment for angle S and angle Y is going to be segment SY. Be sure that you get down what included side means, because it's going to be very important when we differentiate between ASA and this new one right here, AAS. AAS also involves two angles, but this time the side is not between the angles. It's just somewhere else on the triangle. Non-included side for the third side, or for the third part, the S. All right, so the four we've learned about: SSS, ASA, SAS, AAS, and of course SSA is wrong, and so is AAA. Those two do not work at the bottom. So pause the video and name which postulate would prove these triangles are congruent. All right, we have angle to angle, side to side, and angle to angle. The side is between the angles, so it's going to be ASA. There it is. All right, so once again, I'm going to ask you to pause and try to identify on these four triangles which postulate you would use to prove congruence. Okay, on this first triangle, we can draw on the lines because this side will be congruent to itself in both triangles. So you have S, S, and S. SSS congruence. On this triangle, you have angle to angle, side to side, and I don't see anything else. So I'm going to write none on that one because you don't have any other angles or sides that are congruent. On this triangle, you have side, side, and angle. Well, did side, side, angle work out for us? No, it did not. So the answer here will also be none. And finally, here you have angle to angle, angle to angle, and angle to angle. So that's AAA, but that also did not work out for us. Once again, pause and try to identify which postulate would prove these three are congruent. Okay, on this first triangle, you have vertical angles that you need to identify. So you have angle, side, angle, angle, side, angle, ASA congruence. Over here, well, you have a reflexive side, a side that's congruent to itself. So you have side, side, angle, and side, side, angle, once again, does not work. And finally, here in this complicated mess, you have side to side, side to side. No, that's not a side, that's an angle, I'm sorry. Side to side here, angle to angle, side to side. So that's going to be side, angle, side congruence because the angle is between the two sides. All right. So to prove by ASA that these triangles are congruent, I need one more piece of information. So what do you think we need to prove that these two triangles are congruent by ASA? Do we need another angle or a side? Well, I have one angle, check. I have one side, check. So I need an angle. And the side needs to be between the angles, so I need angle B is congruent to angle D. What if I was trying to prove, oh, there it is. Hey, look at that. What if I was trying to prove now that, sorry, let me erase that so it's not in the way, that for AAS now, once again, you have an angle, check. You have a side, check. So you need the angle, but in this case, the side can't be between the angle. So you have to have the angle A is congruent to angle F. Okay, please make sure you do the homework and study up on these postulates for our quizzes and tests. Thank you.